I am now in 6.2, and these are my Hawks practice problems. When I went into Hawks to do the practice problems, these are some problems that I got. So I'm assuming that you guys might see these. All right, so we're still continuing raising a power to a power. So if you don't see an exponent, remember that it's a 1. So 1 times negative 2 is negative 2. There's a 1 right there. 1 times negative 2 is negative 2. And 3 times negative 2 is negative 6. So the first thing I'm going to do to simplify this is I'm going to flip everything over the line because I have all negative exponents. So I have a squared, b to the 6th. When I flipped it over this line, it changed the sign. And then if I bring down 3 squared to the bottom, well, 3 squared is 9. And nothing else simplifies on that one. So for my example 2, I'm going to distribute that 2 to every exponent. So 1 times 2 is 2, so I have 5 squared times m to the 3 times 2 is 6 over 2 times 2 is 4. Well, the only thing I have left to simplify is 5 squared. So 5 squared is 25, 25m to the 6th n to the 4th, and that's my final answer. All right, so now this is all a single term because there's no plus or minus sign separating these. So when I multiply 2 times all of this, my answer is 2x to the negative first y. This is not an exponent. This is just 2 times everything in the parentheses. So the 2 is just attached to the front. Now the only way to simplify this, any step I go further, is to make that exponent a positive. That exponent only belongs to x. So x is the only part of this that has a negative exponent. Everything else stays where it is. The 2 and the y both stay in the numerator. My y gets flipped over the line, comes down to the bottom. I now have all positive exponents, so that's my final answer. All right, so number 4, I'm going to distribute every exponent and that 2 right there. So I'm going to multiply 2 times 2, so I get m to the 4th, n to the 6th over, these both have 1s, so m squared n squared. So now I can simplify the m's and the n's. So the quotient rule says to subtract the exponents. So 4 m's on the top, 2 on the bottom. So 2 pairs would cancel. I'd have m squared left on the top, 6 on the top, 2 on the bottom. I subtract 6 minus 2 is positive 4. Positive exponents stay on the top. And that's my final answer. Number 5. Now if I distribute that 0, I would have 4 to the 0, x to the 0, y to the 0. So if I wrote out 4 to the 0, x to the 0 times y to the 0, basically I would have 1 times 1 times 1. Because anything raised to the 0 power is 1. So that means what I have left is negative 4 times 1. And negative 4 times 1 is negative 4. Okay? So order of operations makes me do exponents first. So I can't multiply that 4 by anything in the parentheses until I deal with that exponent. So raising a power to a power means you multiply exponents. So if this exponent's 1, is it 1 times 0, 0? So that would give me 4 to the 0, x to the 0, because 1 times 0 is 0, and 3 times 0 is 0. So basically this would be 1 times 1 times 1, which is equal to 1. That's where I got that 1. And then after I deal with exponents, according to Please Excuse My Dear Aunt Sally, I would multiply after exponents, and negative 4 times 1 is negative 4. Number 6, we cannot deal with that 3 until we have distributed that exponent of 3 right there. So 3 times 1 is 3, so I'm ignoring that 3 for a minute. So I'd have 6 to the third times b to the 12th, because 4 times 3 is 12. Well, 6 to the third, I'm going to type that in my calculator. 6 to the third is 216. So this would be 3 times 216 times b to the 12th. Well, the last thing I would do is multiply 3 times 216. This is all one term because there's no plus or minus signs. I'm just multiplying 3 times this whole term, which means I'm multiplying 3 times 216. Well, 216 times 3 is 648. So this final answer is 648b to the 12th. That's my final answer. All right, so once again, we have this reminder of our rules page. If you don't see an exponent, that means there's a 1 there. Anything to the 0 power is equal to 1. If you have two numbers that are being multiplied that have the same base, you add their exponents. If you have two numbers that have the same base being divided, you subtract their exponents. If you have a negative exponent, it means you're going to flip the whole number underneath the sign. If you have a negative exponent in the denominator, you flip it up to the numerator. Our next rule was a power raised to a power. When you have that, you multiply the exponents. When you have different numbers and variables together in the parentheses and it's raised to an exponent, make sure you multiply every single exponent by the outside exponent. So a to the n times b to the n. And then finally, if it's a quotient, you still are multiplying every exponent times what's outside, and you're going to get something like that. All right, so now that takes us into scientific notation. So scientific notation is a way to write really big or really small numbers. So if you have the number 7 million, that's a really big number. Well, scientific notation is a way of writing a really big number, a shorter way. So basically, you're going to rewrite this number where there's only one non-zero digit in front of the decimal. So all of these are zeros except for 7. So I would rewrite this 7 or 7.0 because we can only have one non-zero number in front of the decimal. Now this obviously is not equal to 7 million, so we're going to multiply it by a power of 10. Well, a power of 10 raised to an exponent. The way we get the exponent is how many places we moved our decimal. It was originally at the end of the number, and I moved it behind the 7. So that means I moved my decimal 1, 2, 3, 4, 5, 6 places. And however many times I move that decimal is what my exponent is. So let's say I have 53, or let's say I have 530 million. So I want my decimal behind one non-zero number. Well, if I put it behind one non-zero number, that means it would have to be behind the 5. There can only be one non-zero number in front of my decimal. So 5.3. There's a one-digit number right there. That's totally fine. I'm going to multiply it by a power of 10. Well, if my decimal was originally here and I moved it to here, that means I moved my decimal 1, 2, 3, 4, 5, 6, 7, 8 places, and now that's my exponent. So those are really big numbers, right? Well, I can also use scientific notation for very, very small numbers. So let's say I was weighing, I don't know, a molecule. I don't know anything about science, but just pretend I know what I'm talking about. Well, I want to write this very, very, very small number in scientific notation. Same rule applies. You're going to rewrite it so that there's only one non-zero number in front of the decimal. So 4 is a non-zero number. Do you agree with me? Times a power of 10. Well, my decimal was here, and I moved it behind the 4 to make this one non-zero number. So I moved it 1, 2, 3, 4, 5 places. Well, these are really big numbers and they both have positive exponents. Well, the difference in showing a really big number and a really small number, the only thing we can change, since this all looks the same, is instead of having a positive exponent, we have a negative exponent. So our negative exponent is 1, 2, 3, 4, 5. And that is equivalent to this number right here. So the exponent comes from how many places you move your decimal. You're either showing a great big number is represented by a positive exponent, or a very little number, and that's going to be represented by a negative exponent. That doesn't mean this is a negative number. This is a positive number, but we show this is a very small number by our negative exponent. All right, so let's try another one. Let's say I have an even smaller number, and I want to write that in scientific notation. So I rewrite it. I can have one non-zero number in front of my decimal. That is one non-zero number. I'm going to multiply it by a power of 10. This is a tiny number, so I know my exponent must be negative. So I'm moving my decimal from here to here. So I'm going to move it 1, 2, 3, 4, 5, 6, 7, 8 places. So I'm not going to write a positive 8 because that would be a huge number. This is a very small number, so I get a negative 8. I moved it 1, 2, 3, 4, 5, 6, 7, 8 places. That's where that 8 came from. Now, I'm going to show you one of the great things about this calculator. So if you have one, I need you to pay attention. If you don't have one, you probably want to get one. All right, so one great thing about this calculator is it has a scientific notation mode you can put it on. So we're going to all hit our mode button. And when you hit the mode button, you have all these choices. Well, do you see this right here in the middle? It says SCI. That means scientific notation right there. So we need to get to SCI. And the way we're going to do that is we're going to move our arrows down and right, and now do you see that it's blinking? In order to set that, I'm going to hit my enter button. That means I'm picking scientific notation. It's still blinking. I know I hit enter because if you look right there, very, very tiny in the middle of the screen at the very top, it says SCI. That means that we have now placed our calculator in scientific notation mode. When I see that little tiny SCI, I want to get off this screen. The only way to get off the screen is by hitting clear. However, my SCI is still there, which means my calculator is now in scientific notation mode. So I'm going to key in 7 million, and I'm going to hit enter, and my calculator will tell me that this is 7 million scientific notation. So I'm going to hit 7, I'm going to type in 6 zeros, hit enter, and look, it tells me the answer is 7 times 10 to the 6th, which is what we wrote right here. We wrote 7.0, 7 and 7.0 are equivalent. All right, now I'm going to type in 530 million, hit enter, and you see that my calculator agrees that our answer is 5.3 times 10 to the 8th. Now I'm going to type in 0.00004, 1, 2, 3, 4. The number 4 is in scientific notation mode, so my answer is 4 times 10 to the negative 5th. And then finally, I had 1, 2, 3, 4, 5, 6, 7 zeros. So 0.123456723, and my calculator tells me that the answer is 2.3 times 10 to the negative 8. So your calculator is very, very helpful for scientific notation if you keep it in scientific notation mode. Now, you're going to make sure if you try to do a regular math problem now, it's going to give you a crazy answer because it's still in scientific notation mode because of the SCI. So I'm going to clear this. I'm going to go back to mode, and I want it in normal mode. So see NORM. So you're going to key down where now it's on norm. I'm going to hit the key that says enter. And when I did that, if you notice, the SCI went away. So to clear out of this screen, I'm going to hit clear, but I know my calculator is back to normal because my SCI is gone. So now I could do any kind of math problem and it's going to give me a regular answer instead of some crazy scientific notation answer. So that's how you go back and forth. I'm not done with scientific notation. I want to make these numbers in scientific notation, so I'm going to put my calculator back in scientific notation mode. So I'm hitting mode. I'm keying down to SCI. It's blinking. I'm going to hit enter. My tiny little SCI shows up right there, which tells me I am in scientific notation mode. And the only way to get out of the screen is to hit clear. Hit the clear button. But because that's there, I know I'm still in scientific notation mode. So to write this number in scientific notation, I can key it right into my calculator. 8,720,000. When I hit enter, it tells me the answer right on my calculator screen. Now let's say you don't have one of these calculators, or you want to just do it fast and, without keying it in. Well, that's fine too. We know the first number that has to be multiplied by 10 is going to be one number that has exactly one non-zero number in front of the decimal. Well, my only non-zero numbers are 8, 7, and 2. The rest are zeros, so I drop them. If I want exactly one number in front of my decimal, I have to put my decimal after the 8. And you always multiply by a power of 10 with an exponent. And the exponent comes from how many places we move that decimal. Well, if you don't see a decimal, that means it's sitting at the end. So we moved it from here to right there. So we moved it up 1, 2, 3, 4, 5, 6 places. This is a big number. That's what I want my bank account to look like. That means I need a positive exponent. That represents a big number. Now letter B is a tiny, tiny number. Do you want your bank account to show that's how much money you have? That's a lot less than a penny. So we don't like that number. We want a negative exponent. So the only non-zero numbers we have are 3, 7, 6. The rule is that there can only be a one non-zero number in front of the decimal, which means I have to put it behind the 3. I'm going to multiply it by a power of 10. Since this is a small number, it means my exponent has to be a negative. And I moved this 1, 2, 3, 4, 5, 6, 7 places. So -7 is my exponent. Now if I want to use my handy dandy calculator, which you should, why wouldn't you? Why wouldn't you want to use it? Since it's in scientific notation mode, I see my SCI. I'm going to key in that number just like I see it. 1, 2, 3, 4, 5, 6, 3, 7, 6. Hit enter, and I know I'm right because my calculator tells me what the answer is. All right, that takes us to a word problem. Simplify the following expressions by first writing the decimal numbers in scientific notation and then using the properties of exponents. All right, so anyway, it's not a word problem, but that's okay. Now the great thing about my calculator is I can type that in exactly like I see it. It's in my calculator's in scientific notation mode. So I'm going to type that in exactly like I see it and hit enter, and it's going to give me the right answer. So I'm going to hit 0.085 times 41,000. I'm going to toggle down. I'm going to put 0.00017. Now make sure you type it in right. 1, 2, 3, 17. Yep. And when I hit enter, my calculator tells me the answer is 2.05 times 10 to the 7th. All right, so now I'm talking to all of you guys that does not have the calculator that I'm talking about. So let me just show you how you would do that without my awesome, awesome calculator. So what I did was I just put it back in normal mode. All right, so I am going to use my calculator and type this in. All of you should have a fraction button. If not, you can use parentheses. We're going to put parentheses 0.085 times 41,000 parentheses, and now we're going to divide it by the denominator 0.00017, and your calculator tells you that the answer is 205.0000. So this is the answer my calculator gives me. Now that number is not in scientific notation, because scientific notation means you can have exactly one non-zero number in front of the decimal. So I have to write all my non-zero numbers. Well, there's a zero between two non-zero numbers, so I can't drop that number. I have to write 205. I drop all these zeros, but I can still only have one number in front of my decimal, so it goes right there. Now, I got to figure out what my exponent is. Well, if my decimal was here and I put it here, my exponent comes from how many places I moved my decimal. 1, 2, 3, 4, 5, 6, 7. So that is my answer, which is what my calculator did for me. All right, now we have a word problem. All right, light travels approximately 3 times 10 to the 8th meters per second. How many meters per minute does light travel? Well, how many seconds are in a minute? We have 60 seconds equals 1 minute. All right, so if this is per second and we want to know per minute, we got to multiply this times 60, right? So our math problem is 3 times 10 to the 8th times 60. All right, so let's pretend you do have this calculator at first. All right, let's put it in scientific notation mode. We're going to go down to the right. SCI is blinking. I hit enter. To get off the screen, I hit clear, but I still see my SCI. I'm going to type that in my calculator exactly like I see it. I'm going to hit 3, and then there's a button right here that says times 10 to the exponent. Do you see that? Times 10 to the n exponent. Well, I'm going to hit that. That looks just like this. My 8 is what I'm missing. And then I'm going to arrow right. So 3 times 10 to the 8th, and I'm going to multiply, let me go ahead and put this in parentheses, times 60. Or I just could have hit it right here, times 60. All right, and my calculator automatically tells me the answer is 1.8 times 10 to the 10th. Okay? So guys, you really need a calculator like this. It makes this so much easier. If you don't have a calculator like this, then you can just work it out. Whoops. Let me hit enter right here. Get it off of scientific notation. All right, so I'm going to literally multiply this in my calculator. I'm going to say 3 times 10 raised to the 8th power, right arrow, times 60. Oh, I thought I took it off scientific notation mode. Oh, but it's still giving it to me. So without it being on scientific notation mode, it still gave me that answer. So maybe your calculator will too. I'm not really sure, but anyway, if it gives you a huge number, I've already shown you how to write it in scientific notation. So you would just have to do that part, okay? All right, so this is from Hawks. I got these problems straight from Hawks. Now, these first two I could type in my calculator, but I don't need to because basically all it's telling me is how many places to move my decimal. Here I start with a number. It's telling me that I'm going to move my decimal 8 places and I want a great big number. How do I know I want a great big number? Because this is a positive exponent. If I wanted to write this and end up with a very tiny number, I would look for a negative exponent. So since this tells me I'm going to have a great big number, that means I'm going to move my decimal to the right 8 places. Moving it to the right is the only way to make this number great big. Moving it to the left is the only way I'm going to make a very tiny number. So when you see a problem like this exponent is telling you how many times you're moving your decimal. So I'm going to write 3033. All right, my decimal was here, and I'm going to move it 8 places to the right. So I'm moving it 1, 2, 3. The only way to move it 5 more is to make 5 zeros. 1, 2, 3, 4, 5. So my answer is 303,300,000. So I started my decimal here. I moved it 8 places to the right. 1, 2, 3, 4, 5, 6, 7, 8. If I type this in my calculator when it's in scientific notation mode and hit enter, it's going to tell me what this is going to tell me this number right here. Let me try that. Make sure I'm telling you right. I'm putting it in scientific notation mode. Enter. I'm going to write 3.033 times 10 to the 8th. I'm going to hit enter. It's giving me the same number. So in order to make that standard, I'm going to go to my double arrow button right here. I'm going to hit my double arrow button, and it gives me the number right there. Do you see that? 303,300,000, which is what I have right there. Okay? All right, so now this next problem, it's wanting me to write a very tiny number, and I know that because I have a -6. So that means the only way to make this number tiny or smaller is if I move the decimal the other way. I'm going to move it left 6 places. Well, if I move it once, it'd be in front of the 2. So that means I need 5 zeros. 1, 2, 3, 4, 5, 2, 1, 8, 8. Is that a tiny number? Yes, it is. All right, let me double check and make sure I've moved it 6 times. My decimal was there. I moved it 6 times. 1, 2, 3, 4, 5, 6. So that is the answer. Once again, if I type this in my calculator, hit enter, and then hit the double arrow button right there, it would give me on my screen this number right here. All right, guys, we're almost done. 3 more problems and we'll be done. All right, so I have a division problem right here. I'm going to, since my calculator's in scientific notation mode, I'm going to type it in exactly like I see it. 38,000 divided by 0.0002. Scientific notation mode tells me the answer is 1.9 times 10 to the 8th. If I didn't have this calculator, I would just divide that the way it's written. I would take my great big number and convert it to this form. All right, letter B, or what number is that? Number 4. I'm going to type this in my calculator. 2 million. 1, 2, 3, 1, 2, 3, 4, 5, 6 times 0.00046. My calculator tells me the answer is 9.2 times 10 squared. Or you could type this, if you don't have this calculator, you type this into your calculator. It would tell you that the answer is 9,200. You want to move your decimal so that there's only one non-zero number in front of the decimal. That would have told you to move your decimal. Oh, actually, it'd be 920. You're moving your decimal from here to here, and then you would convert it to this formula right here, this form. All right, and then the last one, an atom of gold has a mass of approximately a tiny bit of grams. What is the mass of 9,000 atoms of gold? Well, you're going to multiply. So you're going to take 3.25. I'm going to use this times 10 to the negative 22nd. And then I'm going to multiply that. Whoops, I forgot to get it out of there. So I'm going to do raised to the negative 22. Now don't forget to right arrow. To see my cursor's up here in the exponent. I need it down. Be big, a big cursor. And then I'm going to multiply it times 9,000. Times 9,000. And my calculator gives me the answer because it's awesome. 2.925 times 10 to the negative 18. So that's it. All right, guys, that's 30 minutes. So these have been long videos, but hopefully that will help you guys. I will talk to you soon.